This instructional video is about graphing quadratic function, particularly that is in vertex form. The last series we talked about was in standard, which was y is equal to ax squared plus bx plus c. This time we're going to talk about vertex form, which is y is equal to a times the quantity of x minus h squared plus the k. Now there's something about these things. The h and the k is the actual point, the coordinate of the vertex. And being that the first value, h, is actually the axis of symmetry. So that being said, there are some things we need to identify. So first, a is negative 1/3, right there. That means the parabola is going to open downward. And our values h and k is identified as what's the inverse of positive, so it's going to be negative 1 and 3. And that is the coordinate of the vertex. And of course, the negative 1 is the axis of symmetry. So in fact, this is easier than the standard form that we dealt with in the past. So let's go ahead and start drawing the parabola. Here we go. So the vertex is at negative 1 and 3. So that is the negative 1, which is the x, and 3. 1, 2, 3. There it is. Negative 1 and 3. And since the coefficient a is less than 0, it's negative, it's going to open downward. Okay, so we know what it's going to look like, but we just need to find out where some second points. To draw a line, we need at least 2 points. So I need to get an idea. To do that, why don't we just simply say, well, we want to find out where the y line goes to the y. So let x equal 0. So we're going to take the original function, y is equal to negative 1/3 times x, put 0 in there, and let's evaluate and see what happens. Inside of parentheses, the order of operation says that's going to be 1. 1 squared is still 1, times the coefficient negative 1/3 is negative 1/3 plus 3. And negative 1/3 plus 3 is 2 2/3. So on the y, 1, 2, and around here. And if it's 2 2/3 on this side, it must also be 2 2/3 on this side as well. Okay, so when you draw the line, we have a parabola that looks like this, opening downward. Later on, we'll talk about the solutions of these quadratic functions. Okay, and that's how it's done. Easy. Let's try the next one. Here, you try this one. Y is equal to 3 times the quantity of x plus 4 squared plus 5. Okay, go ahead. Good. Once again, if I write the vertex form of the quadratic function, we have a times the quantity of x minus h squared plus k. Okay, so now we're going to identify some coefficients. A is 3. It's positive. Since it's positive, the parabola is going to open upward. Now the h and the k. H is identified over here as inverse of 4, so it's going to be negative 4, and the 5. We're ready to go. And this, of course, is the x, which is the axis of symmetry. So let's go ahead and draw the coordinate plane. It's that fast. Yeah. Vertex negative 4 and 5. Negative 4. 1, 2, 3, 4. And positive 5. 1, 2, 3, 4, 5. There it is right there. And since it's going to open upward, we need to find, well, we're on the y, or somewhere around here where the second point is. I always like to choose let x equal 0. So we're going to substitute the x with the 0. So we have 3 times the quantity of 0 plus 4 squared plus the 5. And we could evaluate following the order of operation. 0 plus 4 is 4. 4 squared is now 16. Let me rewrite that over here. Multiply to a 3, we got 48 plus 5. Holy moly, y is going to become 53. Okay? So if x is 0, y is going to be 53. You know what? This is only 5. So 53 is going to be like way out there somewhere off the desk. So we can only estimate, okay? So let's just say it goes like woo-hoo-hoo, way up there somewhere that away, and way over there's that away off the table. And let me go ahead and draw the axis of symmetry, at least, you know, write something substantial. There it is. And the vertex is at -4 and 5. There you have it. Enjoy.